Hi everyone. Because we had to go over everything in class this past week rather quickly, because there were a fair amount of absences, I decided to do this video just sort of recapping what we did in class regarding standard deviation and z-scores. If you remember, we looked at an example, two of my students, Andrea and Ben, and these were their test scores over 3 different test scores. They'd each taken 3 tests. And in class, we determined that the mean for Andrea, her mean test score was an 80, and 80 points, 80%, however you want to think of it. And then we had that complicated formula for finding the standard deviation. And the standard deviation for Andrea was 1. And that had to do with the spread. Remember, the mean is a measure of center, and the standard deviation is a measure of variance. So over here, it turned out that Ben, in fact, had the exact same mean score for his tests. His was much more spread out, and after using technology and your calculator or the complicated formula, we determined that Ben's standard deviation was, in fact, 19.97. I'm just going to round it here to 20. Okay, so one standard deviation for him is 20 points, while over here, one standard deviation for Andrea is only 1 point. Okay, so then what we did is we went ahead and looked at this on a number line. Okay, so here's Andrea's number line, and so down here we're going to have her x values. These are Andrea's test scores. Okay. And up here on the top, we had something called z score, z value. Okay, and so that's very important. You always want to be sure to label your axes, because otherwise it really doesn't have much meaning. So right here in the center is where we are going to put Andrea's x score. It is her mean, which was a score of 80. All these values down here are going to be on the lower part are going to be just test scores, and above here is going to be what we call a z-score. So 80 for Andrea is the mean. She has no standard deviations away from the mean, so her number of standard deviations is 0. So we want to think about this. For Andrea, one standard deviation is 1 point. One standard deviation for her is 1 point. Okay, so what would be one standard deviation above her mean? So in other words, here's this space right here is 1 standard deviation, which is just equal to 1 point. Okay, and so that brings her to a score of 81. 80 plus 1 standard deviation of 1 is equal to 81. If she goes another standard deviation above the mean, now 2 standard deviations above the mean, here's another standard deviation, now we're 2 standard deviations above the mean, that would bring her to an 82. And once we get out here to 3 standard deviations above the mean, it's going to bring her to a score of 83. Hopefully that makes sense. So the top number is the number of standard deviations above or below the mean. So if we went this way, this would be 1, we'd mark it with a negative. This is 1 standard deviation below the mean. And for her test score, for Andrea, that would be a 79. Okay. 2 standard deviations below the mean for Andrea would be a 78. And 3 standard deviations below her mean score, this is the mean, is going to be a 77. Okay. All right. Let's go over here now and do the same thing for Ben. See how they differ. Okay. So again, our center is going to be at the mean. So here we go. This is, and for Ben, the center is also 80. That's the mean. Okay. And this is again x, but now x has a different meaning. These are Ben's test scores, not Andrea's, Ben's test scores. And it's important to identify these because for every problem is a little different. So you always want to identify what you're what your x value is. Z, on the other hand, will always be the same. It's just your number of standard deviations above or below the mean. So right at the mean, we are no standard deviations. Okay? Here's where we're 1 standard deviation above the mean. Here's where we're 2, and here's where we're 3. Here's 1 below, 2 below, and 3 below. So z-scores you want to think of, they're just numbers of standard deviations. You can think of it like that. And so for Ben, 1 standard deviation for Ben is now 20 points, not 1 point. So this distance here is still just 1 standard deviation, but down here, this is no longer 1 point. This is now 20 points. So 20 points, 80 plus that 20 points brings you out to 100. So 1 standard deviation above the mean for Ben is going to be a score of 100. 2 standard deviations above the mean is now going to be 120 points, because it's another 20 points above that last one. 40. Now you're 40 points above. You're 2 standard deviations above the mean. So 2 standard deviations for Ben, and so on. And finally up to 140. And we'll just assume that these test scores are possible. So 1 standard deviation below the mean, also this space here now is 20, is going to bring him down to a score of 60. 2 would be 40, and 3 standard deviations below the mean would be 20. Okay. So why do we do all this? What's important about it? Well, let me change my pen color here, and let's ask a couple of questions. So let's say, for example, I'm going to give a 4th test. Okay, I'm going to give a 4th test, and I ask, would it be unusual for Ben and Andrea or to get an 85 on the 4th test? Okay, so at first glance you might just think, okay, well, I'm not really sure. 85, that doesn't sound too hard. Yeah, I would imagine Andrea could get an 85. I imagine Ben would get an 85. And those are reasonable assumptions. However, in terms of statistics, what we're going to do now is we're going to determine what an 85 is. How many standard deviations is an 85 above or below the mean for Ben and Andrea? So let's start over here with Andrea. Well, first of all, her test scores are down here. Okay, so just looking at it, here's an 80, 81, 82, 83. I know 85 must be somewhere around here. I'm going to say an 85 is about here. And my question is, well, what is this number of standard deviations above the mean? What is this number here? How many standard deviations is that above the mean? Well, we know that 1 standard deviation is 1 point. We know this distance is 1 point. We know this distance 1, 1, and so on, 1 and 1. So we can pretty much determine that a score of 85 is 5 standard deviations above the mean. 5 standard deviations above the mean. So in other words, the z-score, z equals 5 for Andrea. Z equals 5. A score of 85 is a z-score of 5 for her. Okay, let's go over here and do the same thing for Ben. Now, where is 85 for Ben? Okay, well, here's an 80, and here's 100. I know there's 20 points here. So I know 5 is not, here would be 10 points. So I'm going to say 5 must be right about here. Here would be for Ben, bringing it down. Here's where his 85 is. Okay. All right. Well, what is his z-score? What is his number of standard deviations above the mean? Well, we know 1 standard deviation for Ben is equal to 20 points. So what is 5 points equal to? How many standard deviations? Well, maybe some of you can figure that out. You could set up a ratio. You could do however you want it, but you may be able to just sort of even think about it. I could say, okay, well, 5 divided by 20 is 1/4, so on. But another way we can do it when all else fails is we have a formula that tells us to find a z-score, it's going to be x minus the mean over the standard deviation. Okay, so in this case, x is this is x, so the numbers down here is x, here's x, that's 85, minus the mean, which was 80, that's where that 5 comes from, divided by the standard deviation, which for Ben is 20 points. You do all that on your calculator, you're going to get a 0.25. So Ben is only 1/4 above the standard deviation when he gets that 85. A score of 85 for Ben is only 1/4 of a standard deviation above. So Ben's z-score is 0.25, while Andrea's z-score is 5. So this might start to tell you, it seems much more unusual for Andrea to get that. Well, in fact, it is. It is actually very unusual for Andrea to get a 5. Yes. Okay. Why? Because we have this magic line at 2 standard deviations above the mean and 2 standard deviations below the mean. Everything in here is usual or not unusual. We usually talk in that way. So if you're out here, it's unusual. If you're over here, it's unusual. And this has to do with that empirical rule we talked about in class. And really what it boils down to is that magic 5%. Okay, if something is 5% or less likely to happen, it's considered unusual. And it turns out, which we'll get more into as we delve deeper into this, it turns out that 95% of the time, or 95% of your data is going to fall between those 2 standard deviations. So the chances of Andrea getting an 85 is 5 standard deviations above the mean. You're way, way out here in that, way less than 5%. The chances of that is less than 5%, so therefore it is very unusual. Okay. How about for Ben, though? Okay, so for Ben, his markers are different because his data is much more spread out. He's much more volatile. He has from 120 down here to 40. Okay, here's his line of usual to unusual. Okay, here's 95% of the time, Ben is going to get scores between 40 and 120. 95% of the time. So he is. So the answer for him here is no. It would not be unusual. He has a greater than 5% chance of getting an 85 on a 4th test. Okay, so that's just sort of the recap of what we did in class and a little bit about z-scores. So try some of the classwork we did and try some of those homework problems.